1 sin 2 pi, then this will be the identity. So B option is true. Maybe if this is multiple choice means third and fourth option also you have to verify. So a power 6, here 6 is cancel, every place is sin pi value cos pi minus 1. So here this also identity won't come. Next again a power 6, every place is 3 will come, 3 pi cos 3 pi minus 1. So only one option is correct, that is second. Okay, you solve like that in solution place, question place don't do. Finished everybody? Next we'll see this question can find solution check it. Eight. Here list positive integer telling, so list 8 only will come. Here a power 8 you will do, then every places will come. Here itself I can do. So every places 2 pi will come. So cos 2 pi means cos pi plus pi, so minus cos pi, again cos pi minus 1, 1 will come. So this is the identity on a power 8. 8 will be the minimum. After that a power 16, a power 24, all are identity, but minimum is 8. If here list positive integer not given have, then we can take out B option and D option both. More than one option will be correct. A power 8 also identity, a power 16 also identity, like that. Finished everybody? So all basic definition, everything we saw. We will see hereafter another definitions, just like orthogonal, unitary, this definition and all we will see. Very important definition, and we are going to enter our next level. So some definition first we will see. First I am writing, just see. Write everybody, then I will explain. Right from here. finish everybody. Okay, I will explain hereafter. Orthogonal matrix means A transpose is equal to identity. Either real entries or complex entries, anything. Real entries means orthogonal matrix we will tell. Complex entries means complex orthogonal matrix we will tell. Why I am here about entries especially telling, because more student I saw they are transpose thinking means that is our mind catching like that. Transpose we will see means that is real entries obviously fixed up. Star we will see means we will fix that they are complex possibility. So orthogonal entries means real always, no complex entries. Like that also I am seeing with a student. So not like that. Any entries, real entries, complex entries, A transpose identity only have to verify. Satisfying means that is called a orthogonal matrix. Real entries means real orthogonal, complex entries means complex orthogonal. Next, unitary matrix. Unitary matrix is A star is equal to identity. Here star already have, unitary matrix have, especially complex unitary no need to write. When star have means when complex entries have must A star, okay, satisfying, no problem. Here especially you have to discuss when real entries, means unitary matrix with real entries. So when real entries have, then this star will change in transpose form. So unitary matrix with real entries, that is called a real unitary matrix, is called a real orthogonal matrix. Okay, real unitary matrix is called a real orthogonal matrix. About complex no need to tell. Unitary matrix tell or complex unitary matrix tell, both are same. So about complex entries no need to tell especially. Star have means complex obviously will be there, but if especially real is there, then that star will change in transpose. But here upper side orthogonal matrix transpose have means that obviously won't change in star. So there must you have to write real and complex both. Idempotent matrix A square is equal to identity. Here you see I am not writing a real entries or complex entries anything. Idempotent matrix definition is A square is equal to identity. Here no transpose, no star, nothing is there. So no need to get confusion. Any entries possibility, any place. A square identity is satisfying, that is called a idempotent. Yeah, A square is equal to A. No. Idempotent means A square is equal to A. Involutory matrix means A square is equal to identity. Any entries, real, complex, anything. Nilpotent matrix A square is equal to A power R equal to 0. R is a least positive integer. R is a least positive integer and R is called a nilpotency index. About this R, later we will discuss. This R is less than n or between 1 to n or R greater than n, R is equal to n. This is later we will discuss. Means about nilpotency index, later we will discuss. Okay, what will be the exactly index? These are very, very important definition. Just you think we have 1, 2, 3, 4, 5. 5 strong pillar I gave. Too much questions are coming from these definitions and too much concepts are from these definitions. Means we will increase more and more by these 5 definitions, more we will use. Too much questions are coming on exam hall related linear algebra, matrix theories. From these all definition related, they will ask more and more concepts. Okay. So day by day we will go more deeply. One thing you do, nilpotent matrix example I will give. No, example I will give, you have to find index. Actually on exam hall you will feel by some question that you need nilpotent matrix counter example. But how to think randomly? Which matrix, which power 0 will come, we don't know. So randomly any matrix you will choose and you will check, verify power 2 0 coming or not, power 3 0 coming or not, power 4 0 coming or not. We will verify, that will be take time. We have no time this much on exam hall. So some matrices we will make for our comfortable, that is we can tell standard nilpotent matrix, and that and all we can use for exam hall for our counter example. Okay. So some matrices I am writing, all are nilpotent matrix. Just you tell me which power 0 coming. Index you have to find. Just matrix multiplication. This is your work. Find this, everybody. So total 6 matrix I gave. Find index and tell me. Online student must find, everybody. Don't neglect. Just matrix multiplication row into column.